set theory, the chapter of set theory. Then we'll have the next quiz, I think probably on Monday next week, on set theory, because we will be done with it with this once we're done with these two examples. So let's get to it. So these are applications of the concepts, some of the applications of the concepts of generalized union and generalized intersection. In that, if a certain set is defined for you, that is, if a collection of sets, I should say, is defined for you with a general formula like this, from there you'd have to find out what would be the elements of the generalized union of these sets and the elements in the generalized intersection of these sets. So here, as you can see, AI stands for any arbitrary set in the union with in the corresponding index value of I. All right. So AI stands for all of the sets or any of the sets in the generalized union or in the generalized intersection. Okay. And for each of these sets, for the elements in each of these sets, we have a general formula for that here. Based on, for this example specifically, in this case, the sets are defined in such a way that the elements in them are dependent on the value of the index. All right. So based on the number of set you're defining, based on the value of the index, that is, you will have a certain number of elements or certain types of elements in the set. Okay. So as you can see here, AI is represented by the formula where we see that the elements start from I, then increment by 1, I, then increment by 1, I plus 1, increment by another 1, I plus 2, then I plus 3, I plus 4, so on until infinite. Dot, 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 so on until infinite. It keeps on going. So each of the elements in this generalized union or the generalized intersection, each of the sets will have the elements based on this definition. Based on this definition, they will have the elements, each of the sets there. AI representing a general formula for all of the sets in the union or intersection. Let's say the first set, for the first set, which is A1, what will be the value of I? I will be equal to 1, right? So the first set where I is equal to 1, just based on this formula, we'll be able to tell what are the elements of this set going to be. What will we have as the elements of the set? It's possible to tell that. Why? Because the formula says that you start from the value of y and then keep incrementing, right? So here for the first set, I is equal to 1. So the elements will start from 1 and then we'll keep incrementing. So 1, then 1 plus 1, so 2, then 1 plus 2, 3, then 4. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on until infinite. That is all positive integers. Okay? That's one. Now, for the second set, A2, what is the value of I? For A2, for the set A2,
2.
I is 2, right? So for the set A2, the elements of the set A2 will start from 2. We will start from 2 because this time the value of I is 2. For the set A2, I's value is 2. So we will start from 2 and then keep on incrementing. 2, then 3, then 4, and so on until infinite. And the numbers that precede the index will be dropped. Then for A3, I is 3, so we will start from 3. So you see we'll get something of this format, something that follows this format. So for A1, you'll have the elements starting from 1 and going on until infinite. For A2, you'll start from 2 and go on until infinite. And you'll have to drop the previous element before the index. The element that preceded the index, you'd have to drop that one. Because as you see from the general formula, the elements, they start from I. For this specific example, they start from the value of I. And for A2, that's 2, so it starts from 2. And for A3, it'll start from 3. And the elements preceding 3, they're dropped. So what will be the elements of A4?
4, 5, 6, 7.
And then what?
To infinity.
So yeah, it keeps on going until infinity. So similarly for A5, it will start from 5 and go on until infinite. A6, it will start from 6 and go on until infinite, and it will keep following that specific pattern. Now, what is the upper limit of this collection? This is a generalized collection, yeah, but at the end of the day, this is a finite collection of this. That is, there
Positive
are,
integer n.
yeah, positive integer n. So n can be any arbitrary positive integer n. N can be any arbitrary positive integer n. However, at the end of the day, even though arbitrary, it's still finite. So we have a finite number of sets here. Finite number of sets, because the upper limit is n, which is going to be a positive integer. So at the end of the day, the number of sets will be finite. We don't know how many sets there will be, depends on what the value of n is, but at the end of the day, it's going to be finite. So that, for that purpose, we need to also define the elements of the last set in this collection. What will be the last set? Which one will be the last set in this collection? When I is equal to n, yeah, that is the upper limit, I is equal to n. So the last set will be an, right? And for an, whatever the value of n is, whatever you specify the value of n to be, whichever positive integer it is, that value is the index for an, right? That is the value of I as well for an. So in the set, we will have the elements n, n plus 1, n plus 2, and so on. Okay. Let's say n is equal to 2. Okay. If n is equal to 2, in that case, we would have the set A1, yeah, and then we will get to the set A2, and that is our upper limit. So that's where we would stop, yeah? And there we would have what? N would be n, n plus 1, n plus 2. So n is 2, so I is 2, so we'd have 2, 3, 4, 5, 6, and so on until infinite. So the only sets that we would have in the generalized union or intersection would be the sets 1, A1, and A2. Okay, if n were equal to 2. So n, just like that, can be any number. What if
Wait.
n were equal to 4? Yeah.
I didn't understand this. Like, why is it A1 and A2 only?
If n is equal to 4, if n can be any positive integer, yeah?
Yes,
If, let's say, if you specify n to be 2, in that case, I, the index, starts from 1 and ends where? N, at n. N is the upper limit of the index. N is where it ends. So here, when you mean the generalized union or the generalized intersection, it means A1 plus A2 plus A3 plus so on until plus AN. So if the upper limit is 2, that is, if n is equal to 2, then the first set you would have is I is equal to 1, is for I is equal to 1, right?
Yes,
I equals to 1, so that's A1. What will be the next set?
A2.
For I is equal to 2, A2. Now n is equal to 2, that's the upper limit. Okay? This generalized union intersection is for what? A collection of sets represented by I representing the sets, I representing the sets, and I's value, the value of I ranging from 1 to n. Okay? If the value of I ranges from 1 to n, and if n is equal to 2, how many I's will you have? 1 থেকে 2 এর মধ্যে I এর কয়টা value পাবা? দুটো value. I will be equal to 1 and 2. As simple as that. And similarly, corresponding sets AI কি হবে? A1 and A2.
Yes, miss.
So that's the reason. So for n is equal to 2, you would have only the sets A1 and A2. For n is equal to 4, for example, what are the sets that you would have?
A1, A2, A3, and A4.
Yeah, where A4, for A4, n is equal to 4, we'd have here 4, 5, 6, 7, and so on until infinite. Okay. So similarly, if n is equal to 100, you would have 19 sets before this A100 set. If n were equal to 100, then before this, you'd have 99 sets, A1 through A99, and then you'd have A100, that is the last set, and inside it would be 100, 101, 102, and so on. Okay? So you see, that is the idea of the last set. Whatever the value of n is, inside the elements reflect that. Whatever the value of n is, that is also I, so it will start from whichever value I have for n, and it will keep going on. Does everybody understand the pattern of sets that we've established based on the definition? before we move into the generalized union intersection, we have to make sure that we understand this part, because this is what you have to do. First thing you have to do is, based on the generic definition of the sets, of the elements of the sets, based on that, you'd have to specify a range of sets which establishes a pattern. Here you see we've specified A1, A2, A3, and then AN, which establishes a pattern. So does everybody understand this?
Yes, ma'am.
Yes, miss.
Okay. If there are no questions, then let's move on to the generalized union. Now, what is the definition of a union? In a union set, you would have all those elements which were there in at least one of the sets in the union. All the elements that were there in at least one of the sets in the union will be there in the resulting union set. Yeah. So in this generalized union, among all of these sets, we will have all those elements which are there in at least one of the sets. So let's start from AN. AN will have some elements based on the value of n. But then, what about AN minus 1? AN minus 1 has one more value, right? AN will start from n. AN minus 1 will start from n minus 1. Okay, so n minus 1 value ta okhane thakbe. Okay, so n minus 1, that value, it's not there in AN. But will we count that in the generalized union? Yes, we will. Because as long as it's in at least one of the set, we will count it. Same goes for n minus 2. There, we have the rest of the sets so far, okay, including the ones for n minus 1. The only extra element that we have is n minus 2. So we will count that as well in the set. And we will keep, and just like that, if you keep going back, you will see that for A3, for example, you have 3, 4, 5, 6, 7, all of that, fine. So in the next set, A4, in A4, will 3 be there? In A4?
Yes, miss.
No.
Think
No, ma'am.
about the elements of A4 based on this definition.
No, miss. There will not be 3.
3 will not be there. But will we count that in the generalized union?
Yes, miss.
Yes. Why is
Yes.
that? Because as long as
Because it will contain A1, A2, A3, all the sets.
yes, exactly.
for the
And as
element.
long as it's in at least one, we will have to count it, right? Similarly, in A2, you have 2, 3. Okay. So 3, we have already seen that it's not going to be there in A4 and the rest of the sets. 2, you can see clearly that 2 is not there in A3, but we will still count 2. Then you go back, A1, we have 1, which is not there in the rest of the set, but we will still have to count 1. All right. So if you think about it, which one is that one set which comprises of all the elements? As you keep moving on to the next set, the elements keep getting dropped. A1 to A2, one element dropped. Then A2 to A3, another element dropped. So the elements keep getting dropped. So which one is the set that has all the elements, that covers all of the elements, combining all
First one.
of them together? The first set.
A1,
A1 has all of the elements. As you keep moving forward, one element gets dropped in every step. A1 is the set that contains all of the elements, okay? So in the generalized union, we will have the elements the same as A1. So the generalized union of all of these sets will be equal to A1, the generalized union. For AI, I representing the index ranging from 1 to n, will be equivalent to A1 for this specific example. Because A1 has all the elements that are there in the rest of the sets, all right? And in the union, we bring in all of the elements, okay? So A1, the generalized union is going to be equal to A1, or it's going to be equivalent to the set that contains 1, 2, 3, 4, 5, 6, and so on. That is the set of all positive integers. Okay, is this clear to everybody?
Yes, ma'am.
Okay. All right. Now let's think about the intersection. What happens in case of the intersection? In intersection, we will count the common elements, right? the elements that are there in all of the sets, the elements that are there in every single one of the sets, we will count only those elements, the common elements. Let's see. Between A1 and A2, the common element starts from 2. 1 is not there. Between A2 and A3, the common element starts from 3. 2 is not there. So if you compare the 3 of the sets together, the elements that are there in all of these 3 sets are what? In these 3 sets, what are the elements that are going to be there in all of these 3 sets?
Ma'am, A3.
3, 4, 5, 6, and so on. All right. So starting from 3, you will have the elements. Starting from 3, you will have those numbers in all of the sets, not the ones before, not 1, 2. Similarly, if you move on to A4, 3 is not going to be there. Between the 4 sets, between the first 4 sets, the common elements are going to be 4, 5, 6, 7, and so on. All right. So you see, because of the fact that as we keep moving forward, one element gets dropped, the elements that get dropped, can they be there? The elements that get dropped, can they be there in the intersection? No, they cannot be. For example, here in A1, A2, A3, we see that 3, 4, 5, 6, 7, 8, all of them are there. But can we keep them in the generalized union? 3, 4, 5, 6, 7? No. Because what about A4? In A4, 3 is not there. Then what about A5? In A5, A4 is not there. And so on. Okay? So do you see the thing here? That is, we cannot count the elements that have been dropped previously because we have to count only those elements that are present in all of the sets. The next set which drops some of the elements, the moment it does it, the elements are not in common anymore. And we can only put those elements there in the intersection which are there in common among all of the sets. So finally, we get to the last set. The last set, which one is it? An. Whatever the value of n is, will there be any set after this one? No, there won't be. N is the upper limit. Remember, for the index, n is the upper limit. So there won't be any set after an. So as we saw so far for this specific example, as you keep moving to the next set, one element gets dropped. So if an doesn't have any next set, if there are no sets after an, will any of the elements in an be dropped?
No, ma'am.
They won't be dropped. Yeah. So an এর পরে কোনো setই নাই. So an is the last set. So n elements, so they won't get dropped. Based on the formula that we have here, as the index keeps increasing, we get rid of the numbers that came before the index. n এর পরে তো কোনো index নাই. So the elements that are here will not get dropped. Also at the same time, are these elements there in the previous sets as well? Yes, they will be there as well. Why is that? Because each of these sets, see, 1, 2, 3, 4, so on until infinite. 1 to infinite, 2 to infinite, 3 to infinite. So an, n এর value যত large হোক না কেন, however large your value of n is, they will be there in the previous set. Okay? See, in A2, you have all the elements that are there in A2 are there in A1 as well. All the elements that are there in A3 are in A2 as well. Similarly, all the elements that are there in A4 will be in A3. Okay? So similarly, you can say that an will also have elements which are there in the previous sets as well. Okay? Because when we say 1 to infinite, it also covers these numbers as well, whatever the value of n is. So you see these elements, first of all, none of them will get dropped because there are no sets after this. This is the upper limit. And also these elements are going to be there. Whatever the value of n is, they are going to be there in the previous sets as well because these go on until infinite. So these will be there in the previous sets as well. So the generalized intersection will be equal to an. The generalized intersection is going to be equal to an, the set an, or the set that contains the elements n, n plus 1, n plus 2, and so on until infinite. Okay? Is this clear to everybody? Or any questions?
No, miss.
Okay, so let's move on to the next example. In this example, the definition that we are, or the general formula that we are going to go with for the sets, the elements of the sets is different. And also you will notice that the range of the index is different. Previously, we had the upper limit at n. Here, the value of I starts from 1 and goes on until infinite. I is equal to 1 to infinite. As you can see, I is equal to 1 to infinite. So the number of sets we will have in the intersection and the union, the number of sets, is that going to be finite? Will we have a finite number of sets in the intersection of the union?
No.
No, we won't, because the index keeps going on until infinite. So the number of sets as well will keep going on until infinite. A1, A2, A3, A4, A5, A6, A6, so on until infinite. Index যেহেতু infinite পর্যন্ত, number of sets is also infinite. So that's why you see there is a difference between how we defined or there is a difference between the sets that we specified here and the sets that we specified here. Here, see that we've specified the last set, which is AN. Here, we haven't specified the last set. But why is that? Because do we know which one is the last set? No. What is the last? There is no last set. It goes on until infinite. It's an infinite number of sets. So there is no last set. So that's why you see here we have defined AN, but here we do not have anything like that because there is no last set. The number of sets is infinite. It starts from 1 and goes on until infinite, the index. The number of sets as well keeps on progressing until infinite. So what we do in these cases, in this sort of range, is establish a pattern, and then we'll assume that once we establish a pattern, the rest of the sets will follow that pattern and keep going on until infinite. Yeah? Okay. Now, let's look at the general formula for each of these sets. We have AI representing all of the sets in the generalized union or intersection, I being the index, and each of these sets will have the elements 1, 2, 3, 4, 5, 6, and so on until I. Okay, that is, the elements in each of these sets will start at 1, and end at I. And in between, you'll have all the numbers that are there between 1 and I. 1 and I এর মধ্যে যদি কোনো number থেকে থাকে, you'll have those numbers in between. So it'll start from 1, increment by 1. এক করে increment করবে. You'll start from 1, এক করে increment করবে, and then end at I, the value of the index. Okay?
Miss, why end at I?
Because that is the definition. I mean, like, see, this is the general formula that you have. Based on this definition, that is the problem. Based on this definition, you have to find out what will be there in the generalized union and intersection. It's there, it's because it's there. So, I mean, in the previous example, for example, you had this specific general, this specific series representing the sets, right? Here, you have this series representing the set. And based on what's given to you here, based on that, you have to find out what will be there in your generalized union and intersection. Okay?
Yes.
All right. So this is so that if a series is defined to us like this, then we know that what should be there in a collection of the sets that fall under this series in terms of union and intersection. And this is something that you will need in these ideas in, I think you'll need them in algorithm, specifically algorithm. Yeah, you might need them there. So yeah, for those purposes. Okay. So yeah, that's the general formula. Now, for the first set, A1, what is the value of I?
Miss, we don't know. It's infinity.
For the first set, A1, in this generalized union,
1.
I
1.
starts from 1 and goes on until infinity. Yes, but the first set, A1, for that, the value of the index is I, yeah? Sorry,
Yes,
is 1, right? Yeah.
Yes.
So, the value of I for the first set, A1, is 1. Now, by the general format that we have here, the elements start from 1 and end at I. For the first set, A1, the value of I is 1. So it will start at 1, end at 1, right? So in between, we won't have any elements. So you see, we'll have increments until I. Until I, we'll have increments until I. So 1 until I. For the first set, A1, the value of I is 1. So 1 until 1, which means we have only one element there. So for the first set, we will have only the element 1. Is this clear?
Yes, ma'am.
Okay. So for the second set, I is equal to 2. So we start at 1, increment by 1, we get to 2. And we see that we have already reached the value of I. So 1 to 2. Then for the third set, I is equal to 3, 1. Increment by 1, you get 2. Increment by 1 again, you get 3. And we've already reached the value of I. For A4, similarly, you'll have the elements 1, 2, 3, 4. Because the value of I is 4. What would be the elements in A5?
Yes.
1, 2, 3, 4.
3, 4, 5.
Okay. Why is that?
We would count up to 5, I guess.
Because I is equal to 5, right? And here we have until I. Yeah. So similarly, it follows that pattern. So A5 would have 1, 2, 3, 4, 5. A6 would have 1, 2, 3, 4, 5, 6. A7 would have 1, 2, 3, 4, 5, 6, 7. And it keeps on going until what? Until infinite. So we have infinite number of sets here. It keeps on going until infinite. So first set has 1. Second set has 1, 2. Third set has 1, 2, 3. Fourth set has 1, 2, 3, 4. Fifth, 1, 2, 3, 4, 5. Sixth, 1, 2, 3, 4, 5, 6. And so on until infinite. Okay. Now, for the
Miss,
union,
what about 800?
for 100, 1, 2, 3, 4, 5, 6 until 100. The first 100 positive integers will be there. But there is no limit, you see here, because it's infinite. So it keeps going on. This pattern.
I'm just kidding. I'm just kidding. Yes, I know.
Okay, all right, cool. Yeah. Okay. Yeah. Yeah, you know what? That was not cool. Okay. All right. Okay, so yeah.
I'm sorry. I'm sorry.
No, don't worry about that. It's okay. I was just a bit immersed in the lecture and yeah, I didn't get it. Okay, never mind. Moving on. So if this is the pattern and we establish that this keeps on going until infinite because we have infinite number of sets here, in the generalized union, what do we have? All the elements that are there in at least one of the sets, yeah? So you see here, the pattern is such that as you keep on moving to the next set, one of the elements increase. A1 to A2, you have one more element. A2 to A3, you have one more element. A3 to A4, you have one more element. The elements keep on increasing as you keep moving on through the sets, right? So in the first set, you had A1 and then you had one more element, then another one, and then another one. And it keeps on progressing. And finally, if you want to form the generalized union, what will be the elements in that set? In order to find that out, we have to see, okay, how far can it go? For I is equal to infinite, what will happen to this range? This definition. What will we have here for I is equal to infinite? 1, 2, 3, 4, 5, 6, so on until what? Until infinite. So 1, 2, 3, 4, 5, 6, so on until infinite, right? So all positive integers for I is equal to infinite. And here you see each element keeps adding, all right? And in the next steps as well, you'll have every next set will have one more element. Every next set. After A4, you'll have one more element in A5. After A5 to A6, you'll have one more element in A6. Just like that, it'll keep adding. So it will keep on adding until what? Until infinite. And in the generalized union, we will put all of these elements there. Why is that? Because as long as it's in at least one of the set, it has to be there in the generalized union. So do you see that each of the elements, they keep adding as you keep going, and they will keep on adding. You will keep on having more elements, one more element as you keep on progressing until infinite, since the limit is infinite, the upper limit is infinite. So you keep on adding more elements. So ultimately, the generalized union will contain the elements 1, 2, 3, 4, 5, 6, 7, 8 until infinite. So all positive integers, okay? Does that make sense?
Yes, ma'am.
Okay. All right. Okay, so what about the intersection then? In case of intersection, we take the common elements, right? The elements that are there in all of the sets will be there in the intersection. If an element is there in all of the sets. Now here, we see that one more element keeps getting added as we have already established. However, the new element is not there in the previous set, right? In intersection, that is the important part. The new element is not there in the previous set. So A4, so in A4 you have one more element here, 4, but is it there in the previous sets? No. And if it's not there in the previous set, can we put it in the generalized intersection?
No, ma'am.
No, we cannot. 3 here is not there in the previous sets. We cannot put 3 in the generalized intersection either. 2 here is not in the previous set. We cannot put it in the generalized intersection. And as you keep on progressing, new elements will get added. But will we put the new elements in the generalized intersection? Will we put the new elements there? No. Because unlike union, in intersection we have to keep the common elements. The new elements will not be there in the previous sets. So we cannot keep the new elements there. So the only element that's there in all of the sets is which one? Which one is the element? Do we have an element here? Yeah, 1. 1 is that element that's there in all of the sets because we started with 1. And hence 1 is there in all of the sets. So that's why the generalized intersection will contain the element 1 and only that one. Okay? So any question regarding this?
No, miss.
Cool. If everybody gets it, then tell me what would we get for the generalized union if I started from 6. That is I equal to 6 to infinite.
Miss, then it will be 6, 7, 8.
1, 2, 3, 4, 5, 6, something like that.
Yes, miss.
Okay.
Could you repeat the question?
So
This
I'm
is
asking that
perfect.
I is equal to, here we have I equals to 1 to infinite, right? What if instead of this we had I is equal to 6 to infinite? That is I started from 6 instead of 1. The indexing. The index here starts from 1, right? What if the index started from 6? What would you have in the generalized union then?
Then 6 to
6,
infinite.
7, 8.
6 to infinite, okay. Okay, makes sense, okay. Everybody agrees, right? That it will be 6 to infinite?
No, miss.
Okay,
A1 will be
Alright,
1, 2, 3,
why?
4, 5, 6.
A1.
But there wouldn't
There
be
is
any
no A1. Are you talking about A6? See, I starts from 6. I is equal to 6, right? So I will start from 6 then. So we will start from A6. We will start from A6, okay? So we will start from A6. First of all, just get that cleared out that we will start from A6. We won't start from A1. Now, in order to answer this question, what happens? First, define what will be there in A6. Then you will get the
1,
answer.
2, 3, 4, 5, 6.
Exactly.
We'll have 1 to 6.
Exactly. So A6 will have 1, 2, 3, 4, 5, 6. So you see, even if the previous sets are not here, that is A1 through A5, even though we're not going to count them, index to 6 থেকে start হচ্ছে, right? So even though we are not going to count them, A1 through A5,
The answer will be 1 to infinite.
yeah. Yeah. So yeah, Fahim, you were correct when you said that the first set would have 1, 2, 3, 4, 5, 6, all of them. But the first set is A6. That's just the only small, tiny detail. Yeah. So since the first set, A6 is equal to 1, 2, 3, 4, 5, 6. What does it mean? Even though the previous sets aren't there, the numbers 1, 2, 3, 4, 5 are still there. So you see, you have to be very careful about this, okay? So if I is equal to 6, first, before just assuming something, assume করার আগে এখানে যেভাবে sets গুলা বানানো হয়েছে, do that, all right? If I is equal to 6, then what will be A6? A6 এর ভিতর কি থাকবে? I is equal to 6, okay, 1, 2, 3, 4, 5, 6. 1 থেকে 6 পর্যন্ত এই নাম্বারগুলো A6 এ থাকবে. So let's first write down that set. And from there, you should be able to tell that, okay, 1, 2, 3, 4, 5, 6 already এখানে আছে, even though the previous sets are not here. So the generalized union wouldn't really change. It would still remain the same. Make sense, guys?
Yes, miss.
Yes, ma'am.
Okay, what happens when we do the same thing for the intersection? Now what happens?
Miss, it
For the
will be
intersection,
We will have 6 to infinite.
miss 1, 2, 3, 4, 5, 6.
1, 2, 3, 4, 5, 6. Yes, 1, 2, 3, 4, 5, 6.
The intersection one. Yeah.
Ma'am, if it's intersection, then it will only be 6, right? If it starts from 6.
For intersection. Yeah,
Yes,
that's
miss.
correct. It's going to be 1, 2, 3, 4, 5, 6. See, obviously it's not going to be from 6 to infinite. I mean, think about it. I mean, haven't we already established that as you move on to the next set, new elements get added? As you move on to the next set, new elements get added. In case of union, the new elements have to be there in the union. The new elements have to be a member of the union set. You have to include the new members in the union set as well. However, in case of intersection, you guys are getting this confused. In case of intersection, the new elements will not be there. So as we've already established that new elements keep getting added as you move on. So the new elements will not be there in the intersection, because in the intersection you have to have only those elements which are there in common among all of the sets. The new elements are not there in common among all of the sets, because the new element is not there simply in the previous set. So it will definitely not go on until infinite, okay? Because the elements that come next are not there in the previous set, okay? Now, for A6, the set starts from where? Set starts from A6, all right? 1, 2, 3, 4, 5, 6. That is the first set. These are the elements of the first set. First set 1, 2, 3, 4, 5, 6. For A7, we will have 1, 2, 3, 4, 5, 6, 7. For A8, we'll have 1, 2, 3, 4, 5, 6, 7, 8, and so on until infinite. All right. However, it started from 1, 2, 3, 4, 5, 6. Okay. So A6 er aage to kono set nei. So these elements 1, 2, 3, 4, 5, 6 are there in the rest of the sets, but since A6 er aage kono set nei, since for the range of I is equal to 6 to infinity, A6 er aage kono set nei, we can say that it's safe to assume that 1, 2, 3, 4, 5, 6, this set, these elements are going to be there in all of the sets. Since er aage kono set nei, er aage jodi kono preceding set thakto, as you have seen here, then you could say that, okay, ager set gulote to sobgulo number thakbe na. How is that in the common intersection? However, A6 er aage kono set nei, it starts from A6. So 1, 2, 3, 4, 5, 6, they're going to be there. In the next sets, we know that er pore set gulote to thakbe for sure. But er aage jehetu kono set nei, we can say that these elements are going to be in common among all of the sets. All right? Is that clear with everyone?
Yes, miss.
Yes, ma'am.
Okay.
Yes.
Okay. So with that, we conclude the chapter of sets. So yeah,